All right, 8.8, the last section of our class. In this section, we're going to get a little introduction to vectors. In this video, I'll just kind of go through some terminology and give you a basic idea of what a vector is. And then in subsequent videos, we'll show you a couple little things you can do with them, and then we'll call it good. So a vector, the way to think about a vector is all a vector is a directed line segment. In other words, an arrow that starts somewhere and goes somewhere else. So this arrow that I drew starts at the origin and ends up here with an x-coordinate of 2 and a y-coordinate of 4. The arrow itself is the vector. Typically we use the letters U or V to represent vectors. So maybe I'll call this guy U. And instead of just calling it U, sometimes you see U with a little arrow over the top, or half an arrow, to represent that this thing is a vector. To signify this guy, I don't want to write 2, 4 in parentheses because 2, 4 in parentheses represents this point, not the arrow itself. So what instead I'll write is something very similar. 2, 4 in these little brackets would represent this specific vector. I know that might seem stupid, like, yeah, it's the same thing. This point, this arrow, well, it's a little bit different. Mathematically, this point is located at 2, 4, but the vector is the entire line that goes from 0, 0 up to 2, 4. And to try to help you see that subtle difference, if we considered the vector that started at 1, negative 2, and ended at 3, positive 2, so this directed line segment right here, close enough to a straight line, it would actually be the same vector. The vector is the arrow itself, not where the arrow itself is located. This vector has an initial point of 1, negative 2, and a terminal point of 3, positive 2. And the vector itself, we would call 2, 4, the 2 representing its length in the x direction and the 4 representing its length in the y direction. It's worth pointing out that instead of using this notation to represent this vector, we could also use the notation 2i plus 4j to represent this vector. It means the exact same thing, it's just a different form. They're actually both called component form. And once we learn a little bit more about what I and j mean, we'll understand how they mean the exact same thing. But for now, if it's easiest, you can just think about this vector that's pictured in both red and in green can be rewritten either in this form or in this form right here. A couple of comments here. We'll focus on two-dimensional vectors, but vectors don't have to be two-dimensional. They could be three-dimensional or even more if we added more components inside here. The other thing that I want to point out is that component form isn't the only way we can refer to this vector that's pictured 2 different times in this graph, because the position of the vector is independent of the vector itself. Maybe to emphasize that fact, I'll redraw this vector without my x and y axes, so it just kind of floats around down here. We don't know what the initial nor terminal points are equal to, but we do know, because of this notation, that to get from the initial point to the terminal point, we travel 2 units in our first direction and then 4 units in our second direction, as pictured here. It's worth pointing out that there's another way that vectors can be referred to. Instead of talking about their component form, often instead what's specified is the direction and the magnitude of a vector. But fortunately, this is all just going to be review stuff from what we saw with polar coordinates. The direction just refers to the measure of this angle that's pictured in green. And the magnitude just refers to the length of the vector, so the distance from the initial point to the terminal point. The direction is typically signified with the Greek letter theta, and for the magnitude, often you see it depicted with these kind of double absolute value symbols. So rather than ask you for the direction and magnitude of this specific vector, I could ask you to find theta and this weird symbol, u, inside this double absolute value symbol. And if u was already defined to you in its component form, maybe you'd be able to figure those out. In fact, I was thinking about ending the video here, but maybe I'll add that topic and then end the video after that. The key thing you need to know to figure out the direction and magnitude of a vector is really it's very similar to figuring out the polar coordinates for the terminal point if our initial point is at the origin. So what I'm saying is if we have this vector floating around anywhere we want, and we know its component form is 2, 4, we can move the vector so that its initial point is on the origin. If we do so, its terminal point would be up here at 2, 4. If we think of the rectangular point 2, 4 and convert those to polar coordinates, maybe you recall that back in 8.3 we learned how to do exactly that with these formulas here. Then for this terminal point 2, 4, x is equal to 2, y is equal to 4. So r in our polar coordinates would be the square root of 2 squared plus 4 squared. In other words, the square root of 20. And theta would be the arctangent of y over x, so 4 over 2. In other words, the arctangent of 2. With a calculator, you might be able to figure out that the arctangent of 2 is about 63 degrees, and the square root of 20 is roughly 4.5. So rather than being told that this vector in its component form is 2, 4, we could say that the direction of this vector is roughly 63 degrees and its magnitude is about 4.5. And just like we can go from rectangular to polar coordinates with these formulas, we can go from polar to rectangular coordinates with these formulas. So if we were told the direction and magnitude of a vector and instead wanted it written in its component form, we could just think about direction and magnitude as the polar coordinates, convert those to rectangular coordinates, and that would give us the point that would be the terminal point of our vector if the initial point is at the origin. Kind of weird, right? We're not doing anything new here. We're just doing the same stuff we've done before. We're just giving it different names, which seems really complicated right now, but there's a reason for defining all this vocabulary and these different names, and hopefully I'll make it clear in the next few videos.